Section 9.2, ANOVA for Regression, Video 4. As I mentioned in the previous video, a lot of times you'll be given this output. And we've seen computer output before when we were looking at just regression before we got into ANOVA for regression. So on the board I have two sets of computer outputs for bivariate data. Bivariate just meaning two variables, comparing sugar content and calories for various types of cereals. This is example 9.10 on page 532 of your book. So if you have your book, you might want to open to that page. I'll admit that in the book they ask a really stupid question. Well, it's not stupid, but it's just too simple. But first, let's take a look at these outputs, because we do have two different ones. Our regression output tells us information about the line of best fit. For our predictors, the constant, aka the intercept, and the explanatory variable, sugar, our coefficients are 88.92 and 4.3103. The standard errors for both of those are here, t-values and p-values. Just a reminder that we don't use most of the information given for the constant. The only one that we use is under coefficients, which tells us what our intercept is. However, everything down here has a meaning and in some cases a purpose. The number under coefficient for sugar would be the slope of the explanatory variable. The standard error would be the standard error when either estimating the population slope or testing the population slope. The value under T is the test statistic when testing whether or not the slope is equal to 0 at a 5% significance level. And the p-value would be the p-value for testing whether or not the slope is equal to 0 at a 5% significance level. Next to it, we have the ANOVA output. Three sources for the variability: the regression, or the model, or the equation, the residual, also known as the error, and the total. Here are our degrees of freedom. Here are the SS's, the MS's, the F statistic, and the p-value for the ANOVA test. In the book, the question is not really a question. It's verify that SS model plus SS error equals SS total. And in this case, they don't. Did I miswrite something? I absolutely did not. But guess why they're not exactly equal? Because these are the results of rounding, and they're almost equal. I believe the sum of these is 35,151. So we're going to attribute the close but no cigar additivity here to rounding errors. For the MS's, it's just the ratio of the SS's to the degrees of freedom. So MS model is the same as SS model, since the degrees of freedom is 1. But if you were to check, 19,834 divided by 28 should round off to 708. And the F statistic, in other words, the test statistic when testing the effectiveness of the model, is the ratio of the MS's. And then its p-value as well. Excuse me, let me get a drink real quick. Now, as a homework question or a test question, there are a lot of things I could ask you. For example, what's the regression equation based off of the regression output? The regression equation would be the predicted caloric content, or predicted calories, if you will, is equal to the intercept, 88.92, plus the slope, 4.3103, times whatever we measure for the sugar. And from that, we could make a prediction about the amount of calories based on a certain amount of sugar. We could interpret the slope. Sugar goes up by 1. We predict calories to go up by this amount. We could interpret the intercept. If the sugar is equal to 0, then we expect this many calories, which contextually would make sense, because it would be possible for a cereal to have 0 sugar in it. We can make a confidence interval estimating the population slope. We've got the standard error. Actually, what we're missing over here is the sample size, how many ordered pairs we have. In the regression output, there is none. No evidence of what the sample size was. what n equals. If we were testing whether or not the slope was equal to zero, we would reject the null hypothesis because the p-value is so small, in which case we would conclude that the slope is not equal to 0. But over here in the ANOVA, if we were testing the effectiveness of the model, we would draw the same conclusion based on the p-value. Remember that the null hypothesis in this analysis of variance is the model is ineffective. The alternative is the model is effective. Because the p-value is less than 5%, we would reject the null hypothesis, accept the alternative hypothesis, and conclude that the model is effective. In other words, that sugar is an effective predictor of calories. Quick question before we move on. How many ordered pairs were used to make this output? There's a hint in the ANOVA table. Do you know the answer? The answer is 30. Why? Because the formula for total degrees of freedom is n minus 1, and that means that n is equal to 30. So when you see computer output now, it comes in one of two flavors. Actually one of three, which we'll talk about later, but for these two flavors, regression output tells you how to build the regression equation and gives you information needed to either estimate the population slope or to test whether or not the slope is equal to 0. That ANOVA output gives you enough information to recover the original sample size and also gives you the means to test whether or not the model is effective.